When a tool like ChatGPT spits out a perfectly written essay in seconds, it's easy to look at the screen and assume you're witnessing magic, or maybe some highly classified alien technology. We're conditioned to believe that these tools are secrets locked away in server farms owned by a handful of tech billionaires. Underneath the sleek interfaces, artificial intelligence is a rigid recipe made up of mathematics, raw data, and basic computer code. AI development focuses on translating the biological architecture of the human brain into mathematical equations. Because this technology is a mathematical reflection of our own biology, the foundational architecture of an AI can be built right on a standard laptop. To start building, we have to look at how we process memory. We recall information because our brain organizes it. A computer needs that exact same level of organization, but in the form of perfectly structured data. Feeding raw text files and random numbers into a computer is the equivalent of dropping 1,000 unsorted books onto someone's desk and expecting them to instantly memorize the contents. Programmers use two specific Python tools called Pandas and NumPy to take that mountain of chaotic information and sort it into clean, highly readable spreadsheets. If the data isn't organized into these clean rows and columns, the mathematical formulas have nothing to process. This structured grid is the absolute first layer of the system. Engineers modeled the neural network on the way human neurons pass signals between one another, creating a digital map of our biological pathways. Neurons use weights to prioritize data. Like rating a camera 80%, AI assigns heavy numerical weights to key information. Next, an activation function acts as a hard filter, like a 33% passing grade, allowing only the strongest signals forward. This network relies on mathematical beats and percentage weights to automatically filter and prioritize the incoming data. Learning usually comes from consequence, like failing a math test or scraping a knee while trying to ride a bike. A loss function acts as a red pen, calculating the AI's exact mathematical error. This triggers backpropagation, which travels backwards through the network to pinpoint faulty neurons. Moving in reverse, it tweaks their weight percentages, ensuring the next guess is closer to the truth. Artificial intelligence is mathematically forced to learn from millions of targeted failures until it reaches perfection. By layering Python code, structured data, and an automatic feedback loop, we've built the logical skeleton of an artificial system. But the machine we just built is entirely blind, deaf, and mute. This system understands the calculus of a loss function and the probability of its own network, but it has zero comprehension of human language. Turning these numerical calculations into a conversation requires the transformer architecture, the breakthrough that finally allowed machines to handle the complexity of human speech. We'll explore exactly how that works in Part 2.